Hi everyone, this is section 2.1 on second differences for integrated 2 KC7. Okay, so you can tell whether a function is going to be linear or a quadratic. Remember, a quadratic is a U-shaped graph by looking at the second difference. Okay, if the second difference is equal to 0, that means that you have a linear function. If the second difference is not equal to 0, if it's some other number, but is constant, remember the constant means that it's the same number, then it is going to be a quadratic function. Okay? So let's go ahead and look at some examples. So I'm going to give you a table of values and a function. Okay? You need to find the first and second difference, then determine if it's linear or quadratic. Okay, so I give you a function y is equal to 2x, and then I give you a table of values from 0 to 4. What you're going to do is to find out what this y value is right here. I am going to plug in 0 wherever I see x in that function. So this is 2 times 0, which is just 0. So my y value is 0. I'm going to do the same thing over and over again with all of these y or x values. So now it's 2 times 1, which is 2. So 2 is my next value. And I'm going to do that again with 2. So 2 times 2 is equal to 4. So 4 is my next value. Do that again with 3. You get 6. And with 4, and you get 8. Now, the first difference is how do I get from 0 to 2? Did I add or subtract, and by how much? Right? So from 0 to 2, all I had to do was add 2. From 2 to 4, add 2. From 4 to 6, add 2. And from 6 to 8, you add 2. Okay, so my second difference is doing the same thing with these two values. So how do I get from 2 to 2? Well, you don't have to do anything. The second difference is 0. There is no change between all of these. So because these are all equal to 0, then my function is linear, which is my final answer. Okay, so let's do this again. Now the equation for the next one, for number 2, is y is equal to 2x squared. It looks almost identical. The only difference is this exponent right here, okay, which is going to change my values. So I have the same table of values from 0 to 4. And all I'm going to do is plug in those values wherever I see x in the function. So I have 2 times 0 squared, which gives me 0. Then 2 times 1 squared. If I plug that into the calculator just like that, I get 2. 2 times 2 squared is 8. 2 times 3 squared is 18. And 2 times 4 squared is 32. Okay, so now again, your first difference is how do you get from 0 to 2? What did you add or subtract? Now here, I added 2. 2 to 8, I added 6. 8 to 18, I added 10. And 18 to 32, I added, what did I add? Sorry, I think I did something wrong here, 32. I added 14, excuse me. Okay, so notice that these differences are different from example number 1. In example number 1, the first difference were all 1. Now that is not the case. They were all the same number in the first example. Now that is not the case in example 2. They're all different. Okay, Okay, so my second difference is there's going to be a change, right? From 2 to 6, I added 4. It's no longer 0. From 6 to 10, I added 4. From 10 to 14, I added 4. Now, this number is not equal to 0, but is constant. It is the same number over and over again for the second difference, which means that this is a quadratic function. Okay, so what I want you to do is go ahead and try number 3 with the function 3x minus 1. All you're doing, the first thing you're going to do is to plug in all of these individual values from 0 to 4 wherever you see x. Okay, so pause the video and then I will show my work on here. So 3 times 0 minus 1 will give me negative 1. All you have to do is plug this into a calculator if you're not sure. Next one, 3 times 1 is 3, minus 1 is 2. 3 times 2 is 6, minus 1 is 5. 3 times 3 is 9, minus 1 is 8. And 3 times 4 is 12, minus 1 is 11. Okay, so my first difference, how do I get from negative 1 to a positive 2? So think about a number line. I need to add 3 in order for me to get to 2. Same thing here. 2 to 5, add 3. 5 to 8, add 3. 8 to 11, add 3. These are all the same, which means that all of these changes are 0 because it's only 3. So because it's equal to 0, that means that it is linear.